Welcome back to the final section of Unit 10. This is Section 6, and we are talking about segment relationships in angles. Now, I have three different scenarios here of things that we will see, as these are going to be the three most common, and really the three that we only have, or the three items that we have formulas for. So the first one we're going to talk about, and we'll do the example right afterwards, is the segments of chords. And what this states, if I go ahead and use some colors here, zoom in, I'm saying that I can take E or AE and multiply that by EB, and that will always equal EC, oops, wrong one, and multiplied by ED. So if you notice that lovely cutting point where they intersect, everything that is connected on AB is going to be multiplied to each other, and everything CD is multiplied to each other. So if I look down here, I can state that if I'm just naming my angles, I can say MN times NL, and that's going to equal KN times NJ. This gives me X plus 2 times X plus 1, and that's going to equal X times X plus 4. So I have to go ahead and FOIL here since I have two binomials multiplied by each other. So I'm going to start with X times X, which gives me X squared. X times 1 is positive 1x, 2 times x is positive 2x, and then 2 times 1 is a positive 2. On the right side here, I have to distribute in. So I have x times x, which gives me x squared, x times 4, which is a positive 4x. From here, I'm going to go ahead and subtract x squared from both sides, and at the same time, I'm going to go ahead and kind of combine steps. I'm going to bring these together. That's going to be a 3x, and I'll go ahead and subtract my 3x from both sides. So this ends up cutting out both of my x squareds, thankfully, and then this is all canceled out as well. So I'm left with 2 to equal 4x minus 3x, which is just x. And this gives me my value of x. Now it's not asking for that, it's asking for the measures of the entire segments. So here's what I have to do. I'm going to take these and say ML. So ML is going to equal x plus 2 plus, since I'm figuring out the measure, not just comparing relationships, x plus 1. So I have 2 plus 2 plus 2 plus 1. Ooh, that's a lot of 2's. So 4 plus 3, which gives me 7. So ML is going to equal 7. And then I'm going to have JK, which is going to be x plus x plus 4. So 2 plus 2 plus 4, that is going to give me jk to equal 8. Notice how they are not the same. It's very likely this will happen quite often. When I'm doing this, I don't necessarily have the same measure. I just know that their relationships are going to be that of proportional in the sense of when I multiply them. So that is the first example here in the first of my segments. Another good thing to kind of help out here is if I were to give these letters and say that this is W, X, Y, and Z. I can say W times X is going to equal Y times Z. And that just kind of gives me some letters to use as well. So coming over here, I have two secant lines now. And again, I'm going to go ahead and give these letters. So this is going to be W and X here. This is going to be Y and Z here. And this is just going to help me identify that information that I need to find. So I'm going to come over here to my highlighters. And I'm going to go ahead and state that EA, this part here, times EB, the entire segment, is going to equal EC, the little segment outside my circle, times the entire segment again. So if I were to use my letters here, I would say W times W plus X is going to equal Y times y plus z. So I have to make sure I do that entire segment there. And if I don't, I do not get the correct answer. So I might have to actually find one of my segments to be able to determine the rest of the information. So let's go ahead and look at example number 2 and use this formula. If you notice here, my x value is one of my interior spots, so I will end up having to solve a little bit different. So I'm going to state that RP times RQ is going to equal RS times RT. So this gives me 9 times 9 plus 11, which is 20. And that's going to equal 10 times 10 plus x, or if I rewrite it in standard form, it's x plus 10. So from here, I have 9 times 20. That is going to give me 180, which equals distributing 10x plus 100. When I subtract 100 from both sides, I get 80 to equal 10x, and then I'm going to divide by 10 to get x by itself, and that's left with 8 to equal x. And that is my value I need for this function. Now, a good way to just double check our answers is if I say 9 times 20 is equal to 10 times 18, because I'm going to add those together. So this gives me 180 equals 180. So yes, I did do this right. A nice, quick, and easy way to check. Okay, my last problem here, or my last formula I should start with, is going to be a secant and a tangent. Now this one's a little bit different because it only has 3 parts. But what I am saying is my tangent segment squared is going to equal EC, so this first part, times the entire side, ED. So if I were to give it letters again, I have x, y, z. I would end up saying x squared is always going to equal y times y plus z. And that gives me just a nice little format to write these in. So I'm going to come down here, and my first thing I want to notice is that I need to find RS. So after I find x, I will have to go back and solve for RS. So let's go ahead and write my formula. So I have RQ squared is going to equal RS times RT. RQ is going to be 10, RS is x, and then RT is going to be x plus 15. So I am given 100 equals x times x, which is x squared, and then x times 15 is a 15x. So because of this, I have to go ahead and subtract both sides by 100 because I have this x squared. This is giving me a lovely quadratic, which I will end up having to factor to solve. So from here, I'm going to go ahead and factor here. And then if you don't remember how to factor, it's pretty much you're finding the last 2 values, or the 2 of the factors of C that will give us B when added together. This is A, in this case is 1, B is 15, and C is negative 100. So I need to think of my values of negative 100, that'll give me 15. Another good method to use is the AC method. This is where I take A times C and I make it equal to B. So if I do A times C, I have negative 100x squared. My B value is 15x. This is really the better method to use whenever you are doing, whenever you have an A value of greater than 1. So let's go ahead and think of my factors of 100. That'll give me my 15. Now I can just go down the factor tree, or I can state that plus 20x and then minus 5x. Because I have to have a positive 15, I need my larger number as a positive as well. So these 2 numbers we can take and we can actually plug in for this part here. So I'm left with x squared plus 20x, minus 5x minus 100. And then I'm going to factor by grouping. I'm going to group the first 2 and group the last two. I did that backwards. First two, last two. And I need to find my common factors. So in this one, I have x, and then I just have x plus 20 left. In my next one, I have negative 5, and that leaves me with x plus 20. So then because these are the same, I can go ahead and take the numbers out front and put them in their own parentheses. So x minus 5, and then x plus 20. So how I solve for my values of x here is I'm going to go ahead and set each of these equal to 0. So I'm going to go ahead and come over here and I'm going to say x minus 5 is going to equal 0. And then x plus 20 is going to equal 0. So if I look at the left equation here, I'm going to add 5 to both sides and I get x equals 5. Then if I look at the right one, I'm going to subtract 20 from both sides and I get x to equal negative 20. Now I have two possible answers here. However, I am only going to use one of them. Since x is also a value of a length, I know I cannot use a negative value because I cannot have a negative length. So since x is a very big deciding factor on this, I have to make sure I use only the positive one to make sure that I only have positive lengths. So coming up here, I also need to find the value of RS. So after all of that lovely work, there we go, we're going to come up here and I'm going to say that RS is going to equal X. So RS, and actually I don't even have to bring it up here. Let me bring that back down to make it a little bit easier to look at. So RS is going to equal X. So RS is equal to 5. And yes, even though it is just the value of x, I need to make sure that I do label that properly. And this is the end of section 6. I will say example 3 is going to be the harder of your options for problems. Just really make sure that you go back to that Algebra 1 skill of factoring to solve. And if that is something that you really struggle with, please make sure you go back and look at some videos from last year, or if you don't have those videos easily available, you can always research some more on reminders on how to factor or ask me later. Have a good one.